Welcome to this next session of virtual laboratories, and today we are going to discuss about the evaluation strategies which can be implemented in the virtual labs. There is always a fear in the minds of the teachers, those who are using virtual laboratories or those who are interested in making sure that the students are engaged even after the college hours, and that basic teacher's apprehension is related to how do I evaluate that student. Now, if you can use technology to solve your problem, the time can be saved and the effectiveness can be increased. So, the first and foremost thing is I am going to present to you and demonstrate you the features which we have already deployed in the virtual labs developed by College of Engineering, Pune. Out of that, first is user records monitoring system, wherein immediately after logging in, the student when he logs in, he will be started recording whatever he is doing while performing the experiment. What do I mean by that is whenever he is using that particular experiment from the virtual lab, the time recording will start. So, at the end of the session, teacher will come to know through a report which student has used which experiment for how much time. Now, that is very, very important, because just by spending time while performing the experiment may not give us the efficiency of the student, but after completing this, if he or she goes through some pre and post test, the teacher will come to know whether he has spent time effectively or not. And that is where the second point, which is equally important, is developing the COs and POs of the laboratory work. Now, when you say CO, it is basically LO, laboratory outcome, and the program outcomes which we all are talking about. Now, using Bloom's taxonomy, the theory is being developed nicely. All those verbs are there in theory, but the Bloom's taxonomy verbs which we are using, these are insufficient to track the actions of a student, and that is the reason as a teacher we have to use such words which are applicable in the laboratory, and that is why we have to go slightly away from the Bloom's taxonomy while developing the lab outcomes. Now, once you have done that, the system will give you the feature in which for each experiment you can write the experimental outcome or the LO, and you can map it to the PO, program outcome. Now, once you have done that, then effectively it can be tracked, because automatically in the database, whenever a student completes the assignment, all these COs mapped will get tracked, and then you will come to know whether the response of a student or the performance of a student is satisfactory or otherwise. There would be a pre-test and post-test configuration. Now, what I mean by configuration is, in most of the virtual labs in the initial phase, we have given them fixed questions for pre-test and fixed questions for post-test. Now, after judging this entire virtual lab project in 3 iterations, we came to a conclusion that if the questions are fixed, then it becomes a monotonous for a student, and probably the students are interested only to copy the right answers. Now, what is needed here, and that is what is being implemented in the system which we have developed at College of Engineering, Pune, is there would be a dynamic question bank which will keep on creating the questions assigned to that lab, and those questions or the challenging assignments would be posed to the student, so that every time there will be a new experiment, the new question set in the pre and post test. Now, these random questions which are there, which you can select for the test, and that is the prerogative of a teacher. Now, as we all are teachers, we have to ensure that the repetition of our job has to be reduced. Then and only then, as a teacher, we can become effective. Now, the question is, how can we do that? We need to participate in this project by applying our knowledge in a chosen domain for developing the question bank. If you participate in that, your load will get reduced because the question bank is ready, and every time you can just add a delta in that question bank, so your time can be saved. There are various type of questions one can pose, like a text question, image question, audio, maybe a video question. All sorts of questions can be put in there. So, there is a variety in the question bank, and that variety can be achieved using that question bank if you develop good questions, quality questions, and then there will be a feedback mechanism which we have developed in the form of a test result. Now, what is that feedback? Generally, the test result is meant for a student to give him a feedback whether he has done well or not. In my opinion, as a teacher, we also need to have a feedback by these test results. And what is that feedback? The feedback is whether that student has understood the concept in the class and then he has implemented or applied that basic knowledge while doing the practical. If there is something wrong, we have to take pain in understanding that, and after understanding we may change our teaching style either in the class or during the laboratory session. Now, that is the feedback which is very, very important for a teacher, and we always need to know that there are certain things which are happening at the background. If we can track them, we get a good feedback. So, test result is basically a good feedback as far as a student is concerned for a teacher. The complete analysis of the experiments are available, and I am going to show you what type of analysis would be there. In industrial world, there is a concept called as a golden batch. What do we mean by golden batch? Is the batch in which the quality of the product is extremely superior, the resources used for producing that product is optimum, and the consistency in the quality is also maintained. Now, in industry, we track such batches and maintain those parameters as golden batch parameters. Now, the same concept we are applying in educational world, wherein we know as a teacher this particular task can be done in this much time with this much efficiency. So, this becomes the baseline for our evaluation. Once you have that baseline of the evaluation, whether student is performing close to that baseline, he is away from the baseline, or he is performing better than that. Now, this can be tracked, which will give me an understanding as a teacher that he is close to the golden batch. So, variance can be reduced as far as the batch is concerned. Now, if you look at the concept, you can go to this portal which I have mentioned here, but with login you can go to this portal because the database is along with this portal. But if you do not want to have this tracking, you still can go to vlab.co.in, which is the site which is available for all the experiments which we all are talking about, and these are the experiments which we have developed as College of Engineering Pune, and there are experiments of course from other my consortium partners also. All put together is a portal which I am talking about. Now, if you go here, the tracking, I am just going to show you few slides of how we are tracking those students. If you see here, I want to know actually from a particular college or for all colleges put together, how much virtual lab is being used. So, the total hits, the total time required per department. This is very, very important that you will get per department, per laboratory, per experiment, per student, per college, how much is the usage of that lab. So, you can drill down to a level of a student, and then you will come to know that, oh, this student is not performing maybe in an unsupervised mode, further hand holding is required for that student, and that is the purpose of tracking. The purpose of tracking is not policing. Let me make this point very clear, because we all are teachers and we hate policing. It has to be an open environment where students are engaged in experimentation and they are taking fun out of it, and that is most important. There is an enjoyment associated with performing the experiments. We can even track what is the daily usage. For example, for a particular track, for a particular slot, you have given them an assignment for performing the experiment at home. So, these are like take home assignments. Now, when you go for take home assignments, what happens basically, tracking a student becomes very, very difficult. Now, here is the procedure available, which makes sure that whatever student is doing is getting tracked. Now, after this, you can monitor the records using student, using yearly usage, total usage, so and so forth. Now, what I am going to do is, I am going to start the demonstration of the laboratory. So, if you go to this lab, which is the beta version of the lab which we all are talking about, once you register by using register, then you will get access to usage of that lab. But the only thing is, I am repeating this statement, if you want to use the lab without the tracking mechanism, you can directly go to the cloud of the consortium called as vlab.co.in, from where without registration your students still can use the laboratory. But as we are adding the evaluation, that is the reason this another beta version lab is made available, and which will be functional, and I am going to show you how to use that lab. Now, I am going to demonstrate you the virtual lab with evaluation framework. If you log in here and sign in, then you will get an access to this lab. Once you get access to this lab, the page would be available which gives you all the details which are there in that page. For example, which labs are available, because today I have logged in as an admin, so that I get all this report, like report of usage, records, feedback report. I can add a college. If you wish to be part of this, I can add a college. Then the experiments would be shown, developed by the entire consortium. Now, these experiments are basically from the consortium partners from various domains like computer, electronics, electrical, biotechnology, metallurgy or other disciplines also. Now, the lab which I am going to demonstrate to you is from the electrical domain, and under electrical domain these are the labs which are available, and for our today's purpose of demonstration, I am going to show you a lab which is called as process loop components lab, through which I am going to demonstrate you how tracking of a student can be done by performing one experiment. So, this experiment is to configure a transmitter for a particular process application. So, if you click on here, then the experiment would start, in which there are various tabs available for you, and using each tab, what you can do is, expected is a student should read what is available there. And the beauty of this is, if you can see here, you will find that the timer is on. Now, the meaning of the timer is how much time that student has spent on each tab. Very, very important, because in most of the cases what happens, students directly jump on the simulator without understanding what is that simulator all about. So, there is a systematic way of performing experiment, and that systematic way and the discipline which we wanted to inculcate in the minds of the student can be done through this. So, this number, this timing will be tracked. So, suppose a student has read this objectives, what is exactly expected from him, and you will find here the Bloom's taxonomy of recall, apply and evaluate, which we have used. But the verbs which are there as far as the industrial usage is concerned, these verbs are slightly different than the Bloom's taxonomy, where you will find recall means identify the suitable transmitter required for the application. Apply means characterize, configure and calibrate the transmitter under test, and evaluate means determine the fault in the working of the transmitter. Once a student has gone through this, what is expected from me at the end of the experiment, then a student can be asked to go to the theory, then the timing will continue, but we know for each tab how much time that student has spent. Now, here there is a prerequisite. We are expecting students to complete these prerequisites, like what is the standard instrumentation signal range, and then there will be an exhaustive theory given to the student, which a student must have done in the theory class, but as far as the practicals are concerned, the related theory is being taken here, and the student will go through this and understand what a 4-wire transmitter is all about, the 3-wire transmitter, how to calibrate that transmitter for various applications. All this theory at one stop solution is available for a student. So, he or she will go through this and understand certain expectations, like I want to find out what is the zero error, I want to find out what is the span error or the accuracy or the linearity. All these things are given to a student before performing the experiment. So, we are expecting that the student should learn all those things, read, capture that, and use this information while performing the experiment. Now, while doing it, you will find this entire information is available to a student, and then the timing would be recorded here. If you can go back, you will find that there is a timing recorded. Now, once you have this timing recorded, that means a student has understood something, he has used certain theory, he must have recollected whatever happened in the class, and then he will go to the procedure. Now, this is based on the student. Please understand, we are not there. We are virtually with the student through the portal. Physically, we are not there with the student, and that is the reason. In my previous session, when I was talking about where is the time for a teacher to track these students, here is a solution, here is a technology which on your behalf tracking the activity of a student, even if you are not there physically there, you are doing your job and the system is working for you, and that is the base use of the technology and computer. So, these are the instructions for usage of the simulator, and we are expecting that there are 6 basic activities which we are expecting. We have developed this simulator like a game. Like we take pride, and most of the students take pride in saying that in this particular game I am at this level, I have attained this level, so and so forth. Similarly, we have same concept here, the gaming concept, in which there are 6 steps and student must move from one step to other step, understanding each and every concept, and in a subtle way he or she is being evaluated. In direct assessment method, we have certain tests in between. In indirect, we are observing what is he doing, which mistakes he is incurring, so and so forth. So, these are the 6 steps which we are expecting a student, and the student will then go through the procedure, understand the procedure carefully, read that procedure, and then after completing this, then and only then the student will appear for the pre-test. Now, this pre-test is the first test of a student based on whatever he has learned and whether the prerequisite is being satisfied and the student is ready to perform the practical is the test. So, once you go for this test, you will find that in this test the student will be asked a question, but again if you see here, a specific time is being allotted for a student, because we need to know that there is a time constraint always in an industry. You cannot keep on working for infinite time, you have to show the results. So, that type of a habit must be there with the students, and that is why the system is posing them challenges by giving the time, saying that now you can solve this assignment, let me understand how it works. For example, now I am going to appear for this test and I will give some answers as if I am a student, I have understood something, I have not understood something. I am not an expert, I am just giving you a demonstration, but I will definitely make sure that the answers would be given. Now, as I have told you, these questions would come from the question bank, and this question bank is so huge that the repetition of questions will not be there. So, that copying of those questions will not be there. These things, important things in this aspect is there will be a randomization of question and there will be randomization of options also. So, that there is a little chance to copy, but frankly speaking, I feel and I propose that we should indicate it to the students that copying, you may complete the experiment, but you may not be in a position to understand what is happening in that, and that is why we have to help that student in telling him that please do it whatever you know, do not try to copy that. So, now what I will do is I will go through the questions. There are 10 questions and then I give answer for each question, keeping in mind that the answers which I have given are used for grading for this experiment. I will submit this and then immediately there will be result indicating that there were 10 questions, you appeared for 10 questions, out of that 4 correct. That means your percentage of marks which you have received is 40%. Now, once you do this pre-test is over, then you will go for a simulator. Then and only then we are expecting that the student to promise us that they will follow the discipline. Unless and until there is a discipline, things will not happen. But please understand, you cannot force them. In such a case, as a teacher, let him step from, instead of pre-test from procedure, let him jump to simulator, and then he will find, or the student will find, that the simulator is becoming difficult for me to operate. I have to go back to the concept and I have to understand the concept and come back as far as the simulation is concerned. Now, once you have this simulation running, you will find that the student, the timing is on, the student is using that. So, what will happen? This page will appear, which is actually a simulator for the level transmitter, which a student is supposed to configure, wire, calibrate and fault find. All these aspects would be here, and these things are in tune with the job profile of an instrumentation and control engineer. So, what we are expecting is a student should do practicals which are very close to application. Close to application means in all the aspects we are expecting that the student would be knowing, and the same thing would be his job profile. Now, what I will do is I will select a level controller. I have a choice, I can select level, temperature, pressure. So, that is the beauty again. You can ask few students to go for level, few to temperature, so and so forth, and then we are expecting the student to read this theory and understand the application. Now, in my previous session also I mentioned about understanding the problem statement in case of a project and understanding the objective of experiment. In lab session, it is always difficult, and without that we cannot ask the student to continue as far as this lab is concerned. So, for example, the student has gone through this, he has gone through this level control system, he has understood everything as a prerequisite, he is aware of all such things, and then he will say that yes, now whatever I have learned, I want to give a test. So, that is another test where we are testing that student. Again the timing will start, and then we will start giving the answers. These questions also will come from the question bank, and these questions would be, or the test would be, typical test for level control system or for the controller which you will be using. So, depending on that, those questions would come, and we are expecting that the student should answer these questions after understanding the concept, after reading the theory, after reading the details which we have already passed on to him, and then he will click on some aspects after understanding, and then he will submit the test, and out of 6, 4 answers are correct. Immediately the result would be given, and the student would be asked that yes, you have done this test, and then after completing the test you are allowed to go for the next level. Now, that is the beauty of it. Unless and until you understand certain thing, let us not hurry and complete the experiment. Now, here let me tell you one more important thing. Failure is allowed. Why? Because now this simulator is available 24/7. A student can practice and come back and go again and keep on doing this. Now, he is supposed to configure this. So, I will say that yes, this transmitter I want to configure, and I want that this would be a 2-wire transmitter. I have selected a span of 0 to 5 meter, and then some questions will be asked to me. So, if you have seen it correctly, the simulator, demonstration of this simulator, you will find that every time there would be a challenge for a student. It is not that these things are just moving without the involvement of a student. What I mean by is, it should not happen that the things are becoming monotonous and the student is just be part of it as a passive listener to this entire episode. It is not. So, here a question is asked to a student that what is the range if the span is 5 meter, and as we know that range is 100% if the span is 85%. So, a student is supposed to put a value here, and then if that value is correct, then and only then it will go to next level. So, for example, I have selected here 4 to 20 and I say that check the configuration. If anything is wrong here, you will receive a message saying that this is wrong, you have to correct it. So, configuration is successful and the student will be asked to go for next level because he has selected and configured correct type of a level transmitter. Now, the next part of this experiment is now you have selected a transmitter. Now, you have to connect the transmitter for a particular application. This is called as a wiring diagram. So, here you will find a library of functions which are given. This lab is developed in a modular way. See, this entire library which we have prepared is helpful for conducting all the experiments under the domain of process loop components like alarm annunciator, high-low selector, I2P converter, control valve, PID controller, all such things can be done. So, now from here the student, if he has understood things correctly, then he will select the components and I say that yes, I need a power supply, I need a 2-wire transmitter, I need an analog input because I want to measure what is the output of the transmitter, and then he or she will connect, and if the connections are all right, so this is how he will connect and he will say that yes, now I want to connect here also, right. And then you will go for check the connection. If there is anything wrong, it will be indicated that there is a wrong connection, but at the back end it would be recorded that you made one wrong connection. Now, it must be known to the student that every mistake, there is no penalty as such, but there is a learning for every mistake, and that is where the student will then go back and check what is wrong actually, and he will say that oh, this is not correct. So, let me check that again, and if your answer is correct, if the connections are correct, it will go to OK, and you can now go to next level. That means now the transmitter is selected, configured properly, wired properly. Now, we have to test that transmitter, whether that transmitter is working properly or not. Now, how do we do that actually is, there are two ways of characterization. You can fit the transmitter and keep on placing the fluid in this tank and find out how much is the level with standard and compare the output of the transmitter. The other way is to go for a calibration where you will give the pressure to the transmitter which is shown in the theory and test it. Now, for observing this or characterizing this transmitter, we can change how much is the level, and I will say that yes, this level is, I add some level here and find out what is the output. So, for each level, whenever I am submitting the reading, for each level the transmitter will start responding me because the connections are correct, the type of transmitter is correct which we have checked, and then what will happen? Just look at this. So, then a student will keep on changing the fluid level in the tank, and then he will or she will observe what is the output of a transmitter. So, this is how the experiment can be done, wherein a student can simply play with number of iterations, right? What should be the frequency at which I should take the readings? How many readings should I take? How do I make a judgment that these many readings are sufficient? All such things can be done by the student and understood by the student every time when he or she is performing the experiment. So, what I am saying is, now you should have this, so add this, you will find here the level in the tank is rising. So, we will come to know that yes, things are moving and the readings are getting recorded. In my previous session, I said that when you are expecting students to do certain critical work, you have to make sure that they are not doing something which is obvious. That is what is the point here. So, all these readings would be noted by the student and the system will take care of it, and then the level in the tank is increasing. I will then say, if I press it again, it will be saying that this reading is already there, you have to check another one. So, similarly, I go on checking the reading and then I say that, oh, this is the reading which I wanted. Now, if I say for my submission purpose, I can do it in soft format, I can download this Excel sheet and you can see here all the readings are now available. And whatever readings you wanted to take, all the readings are available. And then if you say check the graph, then the graph would be there. I will show you the graph which indicates that this particular transmitter has the readings. Just look at those readings which are scattered readings around the main axis. This is the true reading, a graph of the master output of the transmitter, and these are the readings which are actual readings. So, what is required actually is, if I say that I want to now check what is next, is I will go back here and if I press here next level, and if my experiment is not complete, and that is the beauty of this experiment. For example, whenever you are checking that particular transmitter, there is a mandatory requirement that 0 reading has to be there and 100% reading has to be there. Now, I forgot to take that reading. I have not checked whether the tank was empty or not. Now, system indicated me that you made a mistake, you should have done this before. So, I go back here and I submit this. The moment I submit this, the graph would come here and I can again check the graph and I will find the readings are there and they are working, and then I will be allowed to go for next level. Now, this is very important aspect, that self learning is happening here. A student would come to know what is wrong actually and how to correct certain things. So, there is a possibility and there is a support from our side. Even if we are not there, the system is designed in such a fashion that system will create some mistakes in this, or some problems will be associated with that, and student is supposed to solve. For example, now in the next level, a student would be asked another question saying that how much is the 0 error here. So, do you know what is 0 error? Do you know how to calculate the 0 error? Means the actual reading of a transmitter, how much it is away from the master reading. So, master reading or the standard output is 4, but my transmitter is showing 5.72. That means it is a clear indication that it is 1.72. So, a student is supposed to put here 1.72 and submit. If suppose he has put in some wrong value, naturally it will be indicated to him saying that you have not understood the concept of span and 0. Now, that is where I want that this should go to the feedback of a teacher saying that in the class, and if many students have made this mistake, it is a clear indication to the faculty member that the calibration which is being taught in the class is not effective. Let us take this with pinch of salt, and maybe we can go back to the class and repeat that calibration procedure again if many students are making that mistake. Now, here is the span, and I know this span is, I will just put a number here which I have understood, and I put a number here and I say that this is the span, which is all right. But now I want to calibrate the linearity. Now, what we are doing actually is, I calculated, suppose that linearity, and based on that I put some number which I have calculated and I submit. And the moment I submit, there are certain issues that I have to use here the first mistake, but the answer is wrong. I do something and then say that, oh, maybe there is a problem with my calculation, let me go and check once again. Again this is a problem. I go again, I checked it again. Now that is the time which I have to spend while performing the experiment. That is the time where all my mistakes are being tracked at the back end and reported at the back end. So what happens? Still there is a problem. That means it is a clear indication that the intelligence of the system says that you need to know the formula actually. So the formula will appear and the student will read that formula again and say that, okay, I made a mistake, let me check that again. And still if it is wrong, then what we do actually is we indicate him that this is the answer, but let us not forget this answer is after these many attempts, and which will be a penalty for a student. So I submit this. So now I got the answer saying that linearity is 0.947. Then I put here some calculation of accuracy and I put an accuracy and it said it is wrong. I will be doing this and I am saying that, oh, I have done a mistake, let me check again and do that exercise. I would be shown that still after 3 attempts, if you have not given the right answer, here is the formula, can you use it now? So this is something like an hand holding, and this is where your presence will be felt to the student while performing the experiment, that the teacher is coming and helping me by showing the formula. And I say that, okay, let me check again and check, oh, still there is a problem, then we will help that student saying that the answer is 1.02 is the average accuracy of this transmitter. And then the experiment will go saying that the readings are scattered, you need to calibrate it. So you will say yes to that. So this is the next phase in his life when he will say that, yes, in fact I want 4 milliampere at 0, but it is showing me 5.72, that means I have to reduce it. Now that is the logic which we are expecting a student to understand, that whether to increase or decrease, randomly these numbers will come. But please keep it in mind that this entire experiment, when a student will perform another time, then in that case new readings will come, because we have developed this system in such a fashion that random errors would get generated and randomly those readings would change, and every time the student will have different readings. That is the beauty of this system. So he will take a screwdriver and adjust this, and then just look at here, pay your attention to this point, what is happening here. So you will find that slowly I am reducing this current output so as to reach to a standard value, right. So just look at this. Now what is happening here is I am slowly doing it. Now 0 is adjusted successfully because it is now the observed output is 4 and standard output is 4, then it will guide me to the span adjustment. Span adjustment means I wanted 20, but I got 17.09, which is not good. So I have to now here make it positive, right. So I keep on doing this, I keep on adjusting this every time. The number of attempts, now this is the beauty, the number of attempts I am supposed to carry on. There are standard attempts and there are attempts made by the students, and there is a comparison. If you have not understood the concept, if you go to minus and then come to plus, I call that as a trial and error method, and there is a penalty for that. So slowly what will happen, the student will say, oh, I have achieved it, but as a standard practice, whenever you are adjusting span, the slope of the line which you are changing, naturally 0 will get disturbed and I have to adjust that 0 again. That is the procedure, 2 or 3 iterations which you will have to do, and then you will find that you have come to a case where you have adjusted 0 and you have adjusted span also. But now the problem is, if you have seen here, there are certain readings which are scattered. Now this scattering can be adjusted not by 0 and span, because it is a 2-point calibration method which we have used. Instead of that I have to go for linearity. Now in case of linearity, what I am doing is I am trying to find out how many points using this algorithm I can force it to be moved to this line. So, I am making some efforts, and then after making some effort, expected is from the student is what algorithm have I used here to attain these readings. That is the understanding, and that is what we are expecting from the student. So, linearity algorithm you have successfully adjusted, because this is the maximum thing which you can do. You cannot do more than that. That is the reason where you will find that, oh, there is some more scattering is still there which is not being taken care. Can I now go for next? And then I say that yes, let me check that and let me do this second linearity algorithm, and using that linearity algorithm can I move few points again back on the line, so that in the working region of the transmitter at least I will have good linearity. But I still found that the points are there, but still few points are not on the line, indicating that algorithm number 1 and algorithm number 2 are not effective. I will have to go to another algorithm, maybe a piecewise linearization. Now, in this piecewise linearization what I am going to do is every point I am going to pull to the axis. So, that is the algorithm. So, a student is supposed to know what that algorithm is all about, and once I do that, just see what is happening. Now, the thing is the graph is clear, the transmitter is ready to use. But what happens in industry? If you have seen here, for 0 you are getting 4, for 5 you are getting 20, in between that the linearity is achieved. But after few months it is observed that the transmitter is not working properly. There are certain mistakes or there are certain problems in the operation of a transmitter. Now, that is the phase where maintenance and troubleshooting comes into existence, where we say that, oh, there is a problem, and as a maintenance engineer you have to solve this problem. Previously you were a calibration engineer, prior to that you were a project engineer, instrumentation. The roles were there to a student, and we can ask them that here is a problem. What is the problem? Irrespective of change. So, here you will find that some observations are being shown to the students, saying that input is changing, but output is fixed. Can you tell me what must have happened? And there are some reasons, faults. Out of that, a student must select a correct fault. Now, he will check, and if he has understood properly, he will select the fault, and he will say that yes, I understood, and then I put. If I go by trial and error method, sometimes what will happen, I may select right fault, but not continuously. And that is where a teacher will come to know after assessing his result sheet, that whether he has tried with trial and error method or he applied his mind and then he put a fault there. So, if this has happened, then now the next fault is there, which says all the time the transmitter is giving me 20 milliampere. What could be wrong? The transmitter is in saturation mode. So, he will understand that it has happened. Now, what had happened? The third situation. Now, many situations can be generated with the help of teachers. We can even make sure that this database of faults also can be generated or enriched, and you can use that for the students to understand this. So, I say that, oh, that is the fault. Now, after completing this, you must have all faults are detected successfully, and here is a report. Now, but prior to that, we are expecting that the student to go to the post test, and in the post test he has to apply certain rules, and then this method would be available to a student. Now, just look at what it is. If you look at this, this is the entire report of a student. This is the entire report of a student. For example, in test analysis, total question 6, he has answered 4. Range calculation, golden batch is 5. There were no wrong attempts from the student. So, I should appreciate the effort of a student. Wiring diagram, there was one mistake. So, for each activity, there would be a dashboard which says that for each activity, which errors were there, which mistakes were there, and then you will come to know that the student is lacking in basic knowledge, it has not attained. He is lacking in characterization also, but as far as overall performance is concerned, he is excellent performance, because the weightage depending on the job profile weightage of this may be less, and because of that you will find that the student has performed well because he has attained 4 out of 6. That is the good part of it. But what is important here is, this is the report which is available to a student saying that you have spent around 49 seconds on basic knowledge. That means you have not spent sufficient time there. Configuration this much time, and the total time you spent on performing the experiment is 16 minutes and 38 seconds. Naturally, a teacher can ask the student that these are the areas where you have to focus, and these are the areas, even if you have attained a certain level of mastery in calibration and characterization and connection diagram, still there are attempts where there are 4 wrong attempts. That means the accuracy error calculation you have not understood properly. Please go back and do that experiment again, and that will give an understanding without involvement of a teacher. Now, that is the beauty of this system. Without involvement of a teacher, if you can ask the student that I want all these things should be attained, and this is the rule. If you make a mistake, there is a penalty. Keep on doing that. Maybe you can practice on your own. Ultimately, you will receive this without spending teachers' time. This is very, very important aspect of a virtual lab, where your time has to be spent for effective work of developing good experiment, developing the question bank, developing certain faults in the system, or adding some good knowledge to theory part of it. And that is what we are supposed to do. As a teacher, we have to have some delta change in our teaching learning process. Every time we will learn, but while doing it, if you document it properly, what happens? Your life becomes comfortable, and then you can focus more on challenging assignments which can be given to a student, so that you become a successful teacher. See, ultimately the job is to become a successful teacher, so that your students are accepted in industry or in any professional organization. That is the job of a teacher. A teacher is not supposed to go to the class and present few things, tell them the concepts, explain them the concepts, conduct the examination and declare pass or fail. That is not the job of a teacher. The job of a teacher is to ensure that each and every student has learned, and the most important is those who are learning fast, let them get a chance and learn few more things, but those who are not up to the mark, hand holding is required. We have to spend lot of time with such students. So, we have to spare our time for such students. These systems which I have explained to you, these systems will definitely help you in giving an insight what is happening when a student is performing the practical. Now, what I am going to do is, I will go back to that presentation once again, so that we will come to know what is happening there. So, after this presentation, what has happened is, there is a CO-PO mapping, as I have told you. You can add PO, you can add CO for each experiment that is available to you. You can configure a test from the question bank which you have. You can generate the test result, and these test results would be available to a student also. That is the beauty of it. So that immediately after the test, the results are declared, there is no anxiety, and if anything is wrong, I can go back. Now, that is the beauty. It is not that you have failed means you are not up to the mark, come next year. No, there is a challenge for the student. Without wasting time, he can go back and try again. No harm in that, because it is a learning. Examination also is a learning. That is what is the message which we wanted to give. Now, these things I have already shown you, but the point here is, after you complete this experiment and get all the data, you will find, and that is what is our understanding also, that you will find that the students from different domains or from aspects, you will find the student which I am showing here, the performance is excellent, but there is another student whose performance is good because he has not done well. There are many areas where serious lacking is there. There is another area where the student is being said that It's just a satisfactory performance because in major areas he has not attained up to the mark, and there is another area where a student has taken this examination casually, so needs improvement. So, now such type of a prescription can be given to each student. Now, this prescription is person dependent. Based on the pace of learning of a student, a prescription can be developed. The technology is there to help you. It is up to us to decide how to utilize this. I must acknowledge the support extended by Ministry of Education under this National Mission on Education through ICT. It's a good project. For last 11 years we are continuing with this project, and because of this project certain good things are happening. Virtual labs is one of the activity of the National Mission on Education through ICT, NME ICT project. Thank you so much.